Hello everyone, welcome to today's class. In this lecture, we are going to discuss one particular form of limits, okay, that is 1 plus fx power gx. Now, the format goes like this, that limit x tends to, let's say, a. Your fx should be 0, okay, means when you put the value of x close to a, your function should get around 0, and limit x tends to a, gx should tend around infinity. If this happens in that scenario, we can say then 1 plus fx raised to power gx limit x tends to a is equal to e raised to power limit x tends to a fx gx. So you might think the limit doesn't get actually solved. It's just that now fx comes into multiplication, and somehow that makes this idea simple also. And there are some particular cases that I'll start introducing as a standard formula that you can consider. Okay, those we can use it for some questions directly. So not necessarily you have to remember this format. Some questions are directly based on the particular cases, and when those particular cases are not applicable, then you have to remember the standard form. Okay, so this is the standard form. All right. Now let's look at those particular cases, some star cases. The first case goes like this: 1 plus x raised to power 1 by x limit x tends to 0. Okay. Now clearly you can see if we put x as 0, this quantity is tending to 0 and this quantity is tending to infinity. The format is 1 plus 0 raised to power infinity, like this. Okay. Then now if we consider 1 by x as a gx, so gx is tending to infinity. Okay. So this will become, I'll solve it just for your understanding one time. It becomes e raised to power limit x tends to 0. It will become fx is x, gx is 1 by x. What happens is these two cancels. Effectively, we are left with e raised to power 1. So directly learn this case. This is e raised to power 1. Okay. So no need to go through the process. Just directly learn this as a direct case. Similarly, this situation can be given in another form also. It is given like limit, suppose x tends to infinity. Now 1 plus 1 by x raised to power x. Now if you look at the case, it is still the same thing. The 1 plus quantity, whatever the quantity is after that, that should tend to 0. 1 by x is there, x is tending to infinity, so this quantity is tending to 0 and this power is tending to infinity. So the format is always like this. The function should tend to 0, your power should tend to infinity. If that happens, it's still the same format. Okay, so I'll erase this. So this again becomes e raised to power 1. Third particular case is what if you don't have x directly, but if you have something as limit x tends to, let's say, 0, 1 plus lambda x raised to power 1 by x. Okay. Now again I'll show you the steps how this particular case arrives. So the working is like this, still using the same format. This is our fx, this is still tending to 0 and this power is still tending to infinity, so the format is still applicable. So it becomes e raised to power fx multiplied by gx. So limit x tends to 0. Now lambda x multiplied by 1 by x, x cancels, so we get e raised to power lambda. So answer for this is e raised to power lambda. So directly again you need to learn this, no need to go through the working, just understand how things are happening. Okay. And the fourth one, limit x tends to infinity 1 plus lambda by x complete raised to power x. Same thing. Still, if you look at the first 1 plus fx quantity, this fx is still tending to 0 and the power is still tending to infinity. Okay, so I'm not going to solve this one. This one again, same thing, e raised to power lambda. So whatever the coefficient here is, lambda is there, so that will go in power of e. Okay, all right. Now let's go through some illustrations. Limit x tends to infinity 1 plus 2 by x raised to power 1 by x. Okay, sorry, 2 by x raised to power x. Now again, you can clearly see this is direct case of fourth particular case. Okay, the fourth one, clearly you can see your lambda is 2 here if you relate it with the fourth one. Okay, so direct answer is e raised to power lambda. Sorry, e raised to power lambda is 2, no? So e raised to power 2 directly. Yes. This is the benefit of this. You don't have to solve it if you learn these cases. Suppose someone don't want to remember these particular cases and they would want to solve that. Again, not a problem. It's just that you will be taking few steps. Okay, so it will consume time, but you don't have to learn anything extra. So if you want to go through that approach, first of all, check this quantity tending to 0, the power tending to infinity. So the format is applicable. So now check, it becomes limit x tends to infinity. This becomes fx is 2 by x multiplied by gx is x. Cancel them. So again, you are clearly getting e raised to power 2. So your call, directly use fourth standard particular case or solve it like this. I mean, you barely have to write one step, but you have to check whether the format is applicable or not. And don't worry, if the question is given in this form, they will be using this format. So although I'm showing you that this quantity is tending to 0, this quantity is tending to infinity, you don't have to check also. Like for the objective exams, you only have to solve the question. So you don't have to justify why this property is applicable or not. It's just that sometimes the question gets tricky around here. So it's better to check. Okay. But usually it will be following this format. Okay. 99% it will be following this format. Okay. So the moment you see function and their power also in x, function is also f, power is also x, directly understand that this is like fx power gx. Yes. Okay, 1 plus fx power gx. All right, let's look at the next question. Now limit x tends to 0, 1 plus sine x raised to power 2 cot x. Okay. Now again, there are two ways to do this. I'll discuss the both one. First, very fast, very quick. Only check whether the format is applicable or not. Yeah? This is tending to 0. When x is tending to 0, sin x will also be 0. When x is tending to 0, cot will be infinity. 2 into infinity will also be infinity. So format is applicable clearly. It's just that there is a factor of 2 here. Na? So forget about that factor of 2. What you can do with that is you can rewrite this as limit x tends to 0, 1 plus sine x complete power cot x and then complete power 2. Na? Power raised to power, you'll get multiply, na? 2 cot x. So I can rewrite like this also. Now still this format is still applicable, and what I'll do directly is again same thing. It is tending to 0, this is tending to infinity. So for these kinds of question, 1 plus fx raised to power gx, the answer is usually e. So e raised to power, directly I can say 2. But suppose someone wants to check it properly, so what they can go for is answer is e raised to power limit x tends to 0. Fx was sin x, your this cot x was your gx, and the complete power was going on 2. Or if you want, you can take 2 cot x also, doesn't make any difference. Okay, it's just that I have done this step, that's why I'm writing this. Okay, so fine, I'll go for this step directly. Okay, that was for direct approach. If you want, like, you can go for 2 cot x. Now solve this further. E raised to power limit x tends to 0. This is sine x into 2 cos x by sine x. Sine x cancels. E raised to power limit x tends to 0. Now it is only 2 cos x. You know, when x is tending to 0, cos is 1. So this is becoming e raised to power 2. So same answer. Now it's your call whether you want to take more steps. Okay, like first time you're doing, practice these questions like this, but try to understand. You can do this directly also. Okay. All right. All right. Next question. Limit x tends to 1. This is log base 3x complete raised to power log base x3. Again, we'll go through the two approaches, one from objective point of view directly, then from standard way. So first of all, there is no, you can see there is no 1 plus something, but you can see these two things are being multiplied. I can use the property of log AB is log A plus log B. Okay. Usually we learn it like this, log A plus log B is log AB, but we can use it in reverse also. So I'll break this. Limit x tends to 1 log base 3 plus log base 3x. This is log base x3. Now what is log base 3? That's 1, and this now becomes like 1 plus fx raised to power gx. Okay, and limit is x tends to 1. Okay, all right. For this, now what you can do is, you should know this property also. You can write log base AB is same as 1 upon log base BA. Okay, this is also another property of log. So properties of log are required to solve this question simply. So I'll rewrite this question now. Limit x tends to 1 plus log base 3x power 1 by log 3x. Now what you can see is when x is 1, log any base, log 1 is tending to 0. So this quantity is tending to 0. So 1 upon 0 is tending to infinity. So the format is still applicable. Directly the answer is E. Okay, as such. 1 plus fx raised to power gx. Usually the answer is E, because as there is no coefficient also present, so no number is present, otherwise the power will be raised. Or if you want, you can write limit x tends to 1 log fx is log 3x, gx is 1 by log 3x. Usually what happens is these two fx and gx, somehow they will cancel, and mostly you will get 1 as the limit, as long as you don't have any number in the multiplication of fx, or sorry, multiplication of this gx. So again this becomes simply e raised to power 1 or e. Okay, fine, this is done. Let's look at another question. Limit x tends to 0 cos x raised to power cot x. Now what is the problem that you see in this question? You see there is no 1 plus fx there. So what we'll do is we'll forcibly add 1 and subtract 1. So this is one, I'm modifying this question. I am writing this as limit x tends to 0. This is 1 plus cos x. Now I have added 1, so I have to subtract 1 also, and the power cot x. Okay, now this is my fx and that's my gx. Okay, now if we put x as 0, this is cos 0 is 1, so 1 minus 1 is 0. So yes, this quantity is tending to 0. and cot 0 is infinite, so yes, this quantity, sorry, this is tending to 0, this is tending to infinite, so the format is applicable. But interestingly, in this scenario, I don't think this will become 1. We cannot directly say this limit will become 1. You'll see why. I'll tell you that like 99% question, this will be like e only, na? Now this is like the case in which it doesn't happen. This is e raised to bar limit x tends to 0 fx gx, so multiply cos x minus 1 into cot x. Okay, now we have to solve this limit. So what I'll do is I'll just separately solve this and then give the answer. Limit x tends to 0. First of all, I'll take negative common, so 1 minus cos x it becomes. Cot is cos x by sin x. Okay, can we solve it any further? No. Fine, let it be. 1 minus cos x we know, no, at least 1 minus cos x, if I convert it to half angle, this is 2 sin square x by 2. So let's use that. So limit x tends to 0 minus sin square x by 2, this is cos x, let it be. The denominator sin x, I think it will also require breaking, so sin x, I can rewrite this as 2 sin x by 2 cos x by 2, half angle property. Okay, so 2 sin x by 2 cos x by 2, sin x by 2 cancels. Okay, now what is left? Limit x tends to 0 minus sin by cos will become tan x by 2 into cos x. Okay, x is tending to 0. There, now we know that limit x tends to 0, tan x by x is 1, but there is no x present here. So I think we should first of all always try a direct substitution. Let directly put 0. So tan 0 is 0 and cos 0 is 1. So 0 into anything is 0. So I think direct substitution works. So limit x tends to 0, if I do direct substitution, minus tan 0 into cos 0, it becomes 0. So fine, the limit is tending to 0. So I can say that the answer for this is e raised to power 0. We have solved this limit. Okay. So e raised to power 0 is, we can say it's 1. Okay. Fine. So not necessarily every time the limit will cancel each other and you'll get 1, but most of the time that happens. Let's look at the next question. Limit x tends to 0, a raised to power x plus b raised to power x plus c raised to power x upon 3. This kind of question was done in the format of e raised to power x and log, but the problem is now there is a power x. Okay, so first of all we need to generate the format. The format is 1 plus fx, so add 1 and subtract 1 basically. So I'll rewrite this question. Let's say limit x tends to 0, adding 1, then subtracting 1, a raised to power x, b raised to power x, c raised to power x upon 3 minus 1. If we take the LCM, that becomes 3. Okay, complete raised to power x. Now this complete thing is my fx and the power is gx. Oh sorry, power is 1 by x, otherwise the format will not be applicable. Let's check whether the format is applicable. When x is tending to 0, this is a raised to power 0, 1, b raised to power 0, 1, c raised to power 0, 1, 1, 1, 1, 3, minus 3, 0. 0 upon anything is 0, so this is tending to 0, this is tending to infinity, so the format is applicable. So it becomes e raised to power limit x tends to 0, fx multiplied by gx. So a raised to power x plus b raised to power x plus c raised to power x minus 3 upon 3 and into this is fx into gx. All right, now I think now it has the, if you look at the power, e raised to power, that particular thing we have solved it in limits, okay, of exponentials. Okay, so limit x tends to 0. You know what you have to do. You have to give the format is a raised to power x minus 1 upon x. So upon x is here. So first of all, take this 3 outside and distribute 1 1 1 to a raised to power x, b raised to power x, and c raised to power x. So a raised to power x minus 1, b raised to power x minus 1, c raised to power x minus 1. I'll write the format also. And upon x, upon x, upon x. The format is limit x tends to 0. A raised to power x minus 1 is, this is log a. Okay, now like this will become log a, this will become log b, this will become log c, and in addition, and 1 by 3 is there. So log a plus log b plus log c, and this is completely happening in e raised to power. Okay, so e raised to power 1 by 3, this becomes log abc. You can take this in the power of, take this 1 by 3 in power of his. This becomes e raised to power log abc power 1 by 3. You know e and log cancel each other. They are inverse function of each other. So e and log cancel. So this becomes abc power 1 by 3. What happened was e raised to power log x is x. Okay. All right. So the answer is cube root of ABC basically. All right. Next illustration. So you can see this format goes a lot with trigo, exponential, your algebraic expressions, any particular thing it can be merged with. So the possibilities are like infinite. Limit x tends to 8. This is 2 minus a by x complete raised to power tan pi x by 2a. Okay. All right. Again, same problem. Your fx not directly present. The format is not directly here. So we'll adjust limit x tends to a. I'm breaking this 2 as 1 plus 1 like this and complete raised to power tan pi by 2a by x. Sorry, pi x by 2a. Okay. Now this is my fx. That's our gx. When x is tending to a, so a by 1, 1 minus 1, 0, yes. And x is a, so a cancels, tan pi by 2 is infinite, yes. So the format I told you, you do check, but it will always be in the form. So e raised to power limit x tends to a, fx into gx. So fx is 1 minus a by x, gx is tan pi x by 2a. So now this becomes a separate question. We'll solve this limit separately and then put the answer in e raised to power. Okay. So let's solve. So we are solving this limit x tends to a. Let's take the LCM of this. This is x minus a upon x. This one is, let it be tan pi by 2 ax. Now let's convert this in limit of x tends to 0. So I'm replacing x with h. Okay, and I'm putting a minus h. What I'm using is limit x tends to a, fx can be converted to limit h tends to 0, f of a minus h or plus h, your call. Okay. So I'm putting minus h. Or plus h. Let's put plus. Positive will not create a problem, hopefully. Actually, both will be equivalent. So fine, I'll solve with plus. You can solve with minus also. Okay. a plus h also, both can be solved. This is again, if somebody is getting confused how this arrived, this was from LHL RHL. Pretty much if they are equal, then only the limit exists now, so we can replace that. So h tending to 0, this will become a minus h minus a upon a minus h. Okay. I'm replacing a x with a minus h, tan pi by 2a bracket a minus h. Okay. All right. So this becomes limit h tends to 0. A cancels, so this becomes minus h upon a minus h. Let's multiply this. Tan bracket. If I multiply this, I'll get tan pi by 2 minus tan pi h by 2a. Now consider this to be theta. Tan pi by 2 minus theta is cot theta. So I can write this as cot pi h by 2a minus h here, a minus h here. Now what is cot? Cot is 1 upon tan. So same thing, minus h, a minus h, 1 upon tan pi by 2 a h. Limit is still h tends to 0, h tends to 0. Now what I'll do is, you know what you have to do. For tan, what do we use? Tan x by x, limit x tends to 0 is 1. But both thing, x, if x is here, x should match. If 2x is there, 2x should match. So same thing, here it is pi h by 2a, na? So I'll generate that first of all. So I'm dividing this by pi h by 2a and multiplying by pi h by 2a. So the whole limit becomes 1. Okay. So now the question remains, limit h tends to 0 minus h upon a minus h into 1 upon pi h by 2a. I will take in the numerator. This h and h will also cancel each other. Okay. So limit h tends to 0. This becomes minus 2a upon a minus h, and pi is here. And limit h is 0. So let's use direct substitution. I don't think there is a problem because 0 is not generated in the denominator. So if I put h as 0, I get limit h tends to 0 minus 2a upon a into pi. A cancels. So this becomes minus 2 by pi. So the answer of the limit is minus 2 by pi. And this answer will go in power of e. Okay, we were solving this now. So here it will put e raised to power minus 2 by pi. Okay, we solved 2 by pi, we put it in the power of this, so we got e raised to power 2 by pi. So yes, solving this limit was slightly tricky. It used all the earlier concepts of trigo, direct substitution also. Okay, so usually this format is merged with the other forms. All right. Next illustration, very common in the exams, x plus 5 upon x minus 1, limit x tends to infinity, complete power x. Okay, the moment you see some function power, also some function, you should know we have to generate 1 plus fx. So in order to generate that, what I'll do is I'll write 1 plus x plus 5 now. So what I'll generate is I'll generate the denominator. Why? You'll see. All right. X, I can rewrite this as x minus 1 plus 6 upon x minus 1 upon x minus 1. Okay. X plus 5 can be rewritten as x minus 1 plus 6. And I've splitted the denominator in two parts. Now what it generates is 1 plus 6 raised by x minus 1 complete raised to power x. Now this is like fx power gx. Okay, this is our fx. This is our gx. And what was the limit? Limit was x tends to infinity, x tends to infinity. So infinity, denominator is infinity. So this is tending to 0, the power is tending to infinite. So format is applicable. Answer is e raised to power limit x tends to infinity. Fx is 6 by x minus 1, gx is x. Now in order to solve the limits of x tends to infinity, what was the format? We are supposed to generate 1 by x, 1 by x. So I'll take this x in the denominator and divide. Okay, so e raised to power limit x tends to infinity, 6 upon 1 minus x minus 1 upon x. Okay, so what is happening is 6 upon x by x minus 1 by x. It becomes 6 by 1 upon 1 minus x, and x is tending to infinity. So this term is tending to 0. 1 by infinity is tending to 0. So answer is 6 for this limit, and this is in e raised to power. So answer is e raised to power 6. Okay. All right. Next question. Limit x tends to infinite, x square plus 4x plus 3 upon x square plus 2x minus 5. Power again x. So same thing we'll do here also. What we'll do, we'll generate the denominator so that they cancel each other. So x square plus 2x minus 5 I'm writing. Now there is 4x present, so I have to write another 2x. So 2x becomes 4x. There is plus 3, so I have to write plus 8 here. Minus 5 plus 8 is 3. No? And now split the denominator in two parts here, and x square plus 2x minus 5. Okay. So it becomes 1 plus 2x plus 8 upon x square plus 2x minus 5. Complete raised to power x. Now same thing, the limit is tending to x tends to infinity. This is our fx, this is our gx, same thing. Fx is tending to 0, gx is tending to infinite. So limit e raised to power limit x tends to infinity, 2x plus 8 upon x square plus 2x minus 5 multiplied by x. So it becomes basically, multiply the numerator, it becomes 2x square plus 8x upon x square plus 2x minus 5. Again, same format of infinity format. What we have to do? We have to generate 1 by x, 1 by x form. So divide numerator also by x square, divide denominator by also x square. Highest power will divide. So it becomes 2 plus 8 by x. Denominator will become 1 plus 2 by x minus 5 by x square. This thing is tending to 0, this thing is tending to 0, this thing is also tending to 0. So basically it becomes 2. So the answer is e raised to power 2. Okay. All right. Let's look at another question. Limit x tends to 0, tan pi by 4 plus x, this complete thing raised to power 1 by x. Okay. Again, this time we cannot directly generate 1 plus fx. So what I'll do is I'll open this identity of tan pi by 4 minus x, and you should directly know this is 1 plus tan x upon 1 minus tan x, or you use the property of tan a plus b and then put the value of tan pi by 4 as 1. Okay, so limit x tends to 0, this whole thing raised to power 1 by x. Now same idea, what we'll do is we'll generate the denominator 1 minus tan x, but in the numerator there is plus tan x, so we'll write plus 2 tan x and then split it in two parts, 1 minus tan x, 1 minus tan x. Complete raised to power 1 by x. Limit is x tending to 0. So limit x tends to 0. This is 1 plus, now we have to solve for this, 2 tan x upon 1 minus tan x power 1 by x. So this is our fx, this is our gx. Okay, so same thing, e raised to power limit x tends to 0, 2 tan x upon 1 minus tan x into 1 by x. Now limit is x tending to 0, so look at this part, tan x by x, this becomes 1. Okay, so this is e raised to power limit x tends to 0, 2 upon 1 minus tan x. Okay. One standard limit. Now if you want to solve this, usually we should try direct substitution first, because some limit is solved. At least let's try. If we put x as 0, this becomes tan 0 is 0, so 1 minus 0, so no indeterminate form, so e raised to power directly I can say 2 upon 1, that's 2. Put directly tan x as 0, so tan x is also 0. That's your answer for this. All right, last one. Limit x tends to 0, cos 2x complete raised to power 1 upon x square. Okay. So same thing, we will generate 1 plus and 1 minus. So limit x tends to 0, I'm writing 1 plus, then I have to write minus also. Okay, and complete raised to power 1 by x square. Okay, so this becomes fx, that becomes gx. Okay, so this becomes limit x tends to 0. We'll directly generate na e raised to power. So e raised to power limit x tends to 0, fx multiplied by gx, so cos 2x minus 1 upon, sorry, into 1 upon x square. So this is e limit x tends to 0. Now I think if we take negative common, this pretty much becomes a trigonometric limit that we have already solved, 1 minus cos 2x upon x square. Okay, this is kind of like the question, if you want you can go for the standard approach, convert this into sine square also, and you can generate. I can recall a direct result, 1 minus cos mx by x square. The answer for this was m square by 2. So I can say limit x tends to 0. This limit is pretty much m is 2 na, so minus 2 square by 2. So e raised to power minus 2 is the answer. If you remember this result, it will reduce your steps again, make your calculation faster. Otherwise, what you can do is 1 minus cos is 2 sine square x, and then solve the limit. Still you get the correct answer. I'm not saying that that's very lengthy. It's just that this helps a lot. All right. That's it for this lecture. See you in the next class. Good day, everyone.